sperm production is right here. So this is like an irony. This is the endocrine system chart. This shows a thin section through the testis. And what it does, the reason I showed this here was we probably have the same seminiferous tubule. You know how the tubules twist and turn all over the place? If you make a one-plane thin section, you're probably going to see the same tubule section at different points along its length. Okay, I'll go through what's in there momentarily. But the reason that this is shown here is the endocrine cells in the testis of the male are the interstitial cells of the lady. So the little pink cells that you see kind of in between seminiferous tubules are the interstitial cells. So here I have a cluster of them. Over here is another cluster. Here we have a couple. They produce the androgen. Okay, and I'm hoping you're thinking, what is it from my anterior pituitary that triggers that? It's LH from the anterior pituitary. So in the female, the LH surge on day 15 causes ovulation and causes formation of corpus luteum. In the male, LH from the anterior pituitary stimulates the interstitial cells of the lady to produce androgens. So I'm male, my testes produce androgens, release them into the blood. That's because the pituitary is releasing LH. And so it shouldn't surprise you that some guys got upset because they're saying, like, I don't want LH to be called LH in me. So in males, oftentimes we call it ICSH, which stands for interstitial cell stimulating hormone. I mean, I don't care really whether you pick up on that or not, but it's true. If you go to the literature, like if you go to the computer, Google, type in interstitial cell stimulating hormone, it's going to say it's the male equivalent of LH in the female. Identically the same thing. But the target in the male is going to be interstitial cells of the lady. Okay, so with this being a cross-section of the seminiferous tubule, what we can see here is the stage of sperm production. This seems ridiculously hard, but it's very easy. All you have to remember is spermatogenesis is meiosis. And the objective is to take a parent-type cell that's diploid and produce eventually a gamete that's haploid. So in sexual reproduction, the nuclei of the haploid sperm and egg get together and they form a diploid zygote. So the zygote's going to have 46 chromosomes in it. The nucleus of the sperm has 23. The nucleus of the egg has 23. Okay? So we're going to start spermatogenesis out near the circumference of the seminiferous tubule. So all the cells I'm kind of touching with my fingertip as I go around here, those are called the spermatogonia. And they're diploid cells. That's where meiosis begins. Okay? Then, as they divide, their daughter cells are the next step in, and we're going to call those primary spermatocytes. So if I start out here, I have spermatogonia. Next step in, primary spermatocytes. I've not reduced the number of chromosomes yet. We're still diploid at this point. However, next stage in, for some reason the chart shows them in two different colors. We're going to have secondary spermatocytes, either in sort of a brownish purple or a bluish purple. Those are now haploid. So your reduction, division, and chromosomes happens between primary and secondary spermatocyte stage. Okay, so it's spermatogonia, primary spermatocytes, those are the biggies. Then the smaller dark ones, either purple or brownish in color, secondary spermatocytes, those are now haploid. Then we're almost home free. We get to another stage. It looks like a little tadpole. You know how the tadpole's tail is sort of like fleshy and clear looking? Okay. These aren't real sperm. They're called spermatids. They're like baby sperm. And once they lose that fleshy tail and just get like a regular tail, then they're sperm. Okay? So the sperm, look at where they are. The sperm find themselves in the lumen, so they're ready to move through the lumen on the way to the root testis, efferent ductules, and then to the epididymis. Let me just check you on this. If I take that sperm right there and try to fertilize an egg with it, am I going to be successful?
No.
No way. Not mature yet. The sperm have to mature in the epididymis for X amount of time before they're viable. Okay. There are also some nourishing type cells that are in the seminiferous tubules. We have different names for them, like sustentacular, Sertoli, that kind of thing. The big purple blobs that you see, those huge cells, those are those nourishing type cells. They simply produce secretions that nourish the developing sperm. Okay? So where are my interstitial cells of lady? among the coils of the seminiferous tubules. In the seminiferous tubule wall, I have my stages of spermatogenesis, spermatogonia, primary spermatocytes, secondary spermatocytes, spermatids, sperm, sustentacular cells or Sertoli cells produce nutrients and other secretions that assist the developing sperm. That's it. Okay. So the final